All right. Hello, everyone. Welcome to class. We're going to continue our discussion from the Stewart textbook. And this time around, our focus is actually going to be on section 10.4. Okay, so that's going to be our focus in this class. So 10.4, so let me get a black pen. So 10.4 actually focuses on 10.4 focuses on areas and length in polar coordinates. Okay, so remember that chapter 10, we're studying a couple of things from chapter 10. And in chapter 10, we had looked at how to convert from Cartesian to polar. We had looked at in 10.3, the most recent, we ended up with sketching the four-leaved rows. Okay, so we're still going to do an extension of that in a way in this class. Okay, so let me make a sketch. So suppose I have a sector, okay? So this is my O. I have this guy splitted into half. Suppose the angle subtended here is called A. Let's assume that the angle subtended here is even called B. Okay, so this guy is going to be theta equals B, while this guy is like theta equals A. Now suppose I have a polar curve, okay? Suppose this is a polar curve across it. I call this guy my region R. So let me use my red pen, call this guy region R. And then this polar curve is defined by R equals F of theta. Okay, I'm not going to go into theories here. I'm not going to go into theories. You can look at the Stewart textbook for the theory of this part. But the formula I want to write now is still kind of based off the idea of, the Riemann sum, area under the curve, those kind of things that you studied before now. Okay, we discussed them extensively in some other sections that we looked at. Okay, so the formula for the area A of the polar region R is actually given by, okay, so in this case, A, A to B, just like area of a sector, 1/2 F theta squared D theta. But remember that our polar curve itself is defined by R equals F of theta, right? So I can do some kind of, replacement. This is A to B, it's going to be A to B 1/2 R squared D theta. Okay. So again, my goal is not to, discuss the theories in this section. I just want to present before you the formulas we're going to use. Any of these formula will work, they're the same, and then we'll solve examples. All right. So the first example for the day is kind of an extension of the four-leaved rows, but particularly in this case, we are finding the area enclosed by just one loop. Okay. So let me write it. Find the area enclosed by one loop of the four-leaved rows. R equals cosine of 2 theta. Solution. I always advise to, make a sketch of your curve, all right? In your geometry. So the four-leaved rows, this guy is just one loop, all right? This is one loop. This guy is another loop. All right. So this guy is even another loop. And this guy is another loop, okay? The four-leaved rows. Now, but the question is concerned about just one loop, okay? So think about this. This guy is 90. If you split this guy into two, this guy is going to be pi over 2, right? So let me do the same thing here. Okay, let me do the same thing here. Now remember that when we're moving counterclockwise, what happens to the angle, guys? The angle is positive, right? So that means this is theta equals pi over 4. But when we move clockwise, the angle is negative. Okay, so that means this guy is even going to be theta equals negative pi over 4. Now, again, remember, I told you guys that that is just one loop. So because that guy is just one loop, that means it's enclosed by from negative pi over 4 to positive pi over 4. Okay, keep that in mind. My area is from negative pi over 4 to positive pi over 4. 1/2 r squared d theta. All right, so but what do we know? This r squared, this guy is even. Okay, so whenever it's even, or perhaps we have some kind of symmetry in this case, just write this guy as 2 from 0 to pi over 4, 1/2 r squared d theta. Okay, so of course, obviously, this is 2 times 1/2, 0 to pi over 4, r squared d theta. Okay, so what do we see, guys? This guy gets off. So this a becomes from 0 to pi over 4, r squared d theta. Okay, but what is r? R is cosine of 2 theta, right? So I can do some kind of replacement. So this guy becomes cosine of 2 theta, but remember, there's going to be a square. Well, you know, do we remember the half angle formulas? Cosine of x, cosine squared of x is just 1 plus cosine of 2x divided by 2. So I can even replace that guy, but in this case now we're dealing with 2 cosine squared of 2 theta, right? This is going to be cosine squared of 2x becomes 1 plus cosine of what, guys? 4x divided by 2. Okay. All right, so let me make progress. So my area is going to be 0 to pi over 4. So in this case, right now I'm going to have a 1/2, 1 plus cosine of 4 theta, right? D theta. Okay, guys, I can pull out 1/2. So I'm left with 0 to pi over 4 of what? 1 plus cosine 4 theta d theta, right? So far, so good. We're fine. So now I have to integrate this guy. Remember, you still have a 1/2 up front. So if you integrate that guy, you have a theta plus 1 over 4 sine 4 theta. But that's a definite integral. So that means you're going from 0 to pi over 4. Okay, you just have to plug in your bounds. So my a becomes 1/2. So plug in the top, you have a pi over 4 here, plus 1 over 4. Then you have a sine 4 times pi over 4, right? Now, I don't have to bother about the lower bound because it's just 0, okay? Sine of 0 is 0, and 0 is exactly 0, okay? So this guy is going to be 1/2 pi over 4 plus 1 over 4 sine of pi. Okay, so at the end of the day, my a is just pi over 8. Okay, so that means that the area enclosed by one loop of the 4-leaved rows is pi over 8. Okay. All right, so let's look at another example. Example 2. So suppose I give you a region. Okay, so I can just give you guys a sketch. Let me call this is my region R. Okay. So the question is, find the area of the shaded region. R is given to be ln of theta, but my theta is between 1 and 2 pi. Okay, it's between 1 and 2 pi. So let us see. What do we do, guys? The formula is a equals integral from a to b, right? 1/2 of r squared d theta. What is my A? Of course, this guy is my A, right? This guy is my B. I got 1 to 2 pi, 1/2 square root of ln of theta. But again, remember, you have a square, d theta. What do I know, guys? This is, I can pull out 1/2. This guy becomes 1 to 2 pi of ln of theta d theta. But can I just, quickly remind you that, recall that when you integrate ln of x, this is x ln of x minus x plus c. Okay, so my A is this guy, 1 to 2 pi ln of theta d theta, right? This would be 1/2. Now, if I integrate this guy, I know what it is right now. Okay, this is theta ln of theta, right? Minus theta, and then you have 1 to 2 pi. So just do plugging in of stuffs, right? Plug in the top and the bottom. 1/2, this is going to be 2 pi, right? Ln of 2 pi minus 2 pi. The whole of this is just exactly the top, right? This is the upper limit. So just want to use a bigger bracket. That guy is the top minus, what about the bottom? Put a parenthesis here. This is going to be ln of 1, which is 0, of course, minus 1. So my area is just going to be, you have a 1/2, which is 2 pi ln of 2 pi minus 2 pi. Okay, so this guy is 0. You have 0 minus 1, that's a -1. -1, 0 minus -1, that's like +1, right? Because negative multiplies by negative, you have a positive. Okay, so finally, I can just distribute by 1/2 if I want. So at the end of the day, I can just simplify to give me this guy. Okay, so these are, easy calculations. These are easy calculations. Just, that's why we learned the concept of integrals beforehand so that you can apply them. So now let's take it a little bit higher. Let's take it a step higher. Example 3. Find the area of the region that lies inside the circle. What circle? R equals 3 sine of theta. And outside cardioid, okay, cardioid, okay, R equals 1 plus sine of theta. Okay, I'm going to sketch what it looks like. Now, what do I do in this case? There are a couple of steps to take. Now, if you remember how we found the area between curves, where we found the POI, and that's the point of intersection. You sketch your curve, you do the top minus bottom, those kind of thing. But essentially, what I just want to pick from here is the fact that we might have to, we will have to find POI. Okay, so but in this case, we'll see how we go about it. Okay, so let's see, it's still the same thing we do before now. So let me make my sketch, right? Okay, so keep in mind that this guy is a circle, right? So I do have something like this guy. Okay, so let me try if I get something better on my second try. Okay, yeah, I hope this is better. My second try. So this guy, is r equals 3 sine of theta. Okay, so but what is this cardoid? Okay, so cardoid looks like this guy. The reason why I'm not, of course, in 10.3, we actually learned how to sketch these guys. Okay, so if this is a test, you should be able to sketch each of those guys. You know how we did that in 10.3, and that's the essence of 10.3. So where you can put up the tables, you can go from, say negative 2 pi to 2 pi or negative pi to pi, and then you plot it. Okay. So, but oftentimes for those that have names, like the 4-leaved rows, so it's kind of standard, right? So that means that you expected to know that. If I say 4-leaved rows, then you know what that means. This guy is a cardioid for 1 plus sine of theta. Okay. So the next point of interest, remember that the formula we're working with is like a to b 1/2 r squared d theta, right? I need to know my lower bound and my upper bound. So, and that's where the point of intersection comes to mind. Now, how do we do that? We set them equal to themselves. You have to set the two polar curves equal to themselves. R equals 3 sine. So that means I know this R equals this guy, right? And also R equals this guy. So I set them equal to themselves. Then I solve for theta. Okay. This is 2 sine of theta equals 1. What's going to be sine of theta? This is 1/2. And that means theta is going to be the inverse sine of 1/2. Okay, now this is where you need your unit circle. Okay, so sine inverse of 1/2 is pi over 6, but is that all? Not quite. And then 5 pi over 6. So these two guys, sine of these two guys will give you 1/2. Okay, so you need your unit circle at this point to be able to tell you what other angle gives the same, the same answer. Okay, so we know our A now and our B. The smaller one is going to be the lower bound. The bigger one is going to be the upper bound because your area cannot be negative, right? All right, so in this case now, this is my A. Now, let's go back to our geometry. So I got this guy. Okay. And then this part is a point of intersection, right? Let me make this guy better. Okay. So over here, the first guy is theta equals pi over 6, right? And in this quadrant, theta equals 5 pi over 6. Let me write this well. Okay, so what do I know, guys? This is going to, I know I do have a pi over 6 and 5 pi over 6, right? But now go back to the curve. There's a curve on the top and there's another one that lies below it, right? So that means I'm free to do top and bottom. Okay, remember top minus bottom. So this is 3 sine theta all square d theta, because that's what you have on the top, r equals 3 sine theta, and on the bottom you have 1 plus sine theta lying beneath it. All right, minus pi over 6, 5 pi over 6. It's still going to be the same 1/2 1 plus sine of theta d theta. Okay, so now if we go back to this geometry, you can see clearly that this curve is actually symmetric about the vertical axis. Okay, if you look at it, it's totally splitted into, the same halves. So now you have to also consider symmetry in 10.4. It makes things easier and it allows for, correctness as well. So since the region is symmetric, okay, I can go back and show you guys that. This guy is symmetric about the y-axis, or perhaps the vertical axis in this case, okay? Symmetric about the vertical axis, okay? And that's theta equals pi over 2. Then what happens? My area becomes 2. Of course, I can pull out this 1/2. This is going to be pi over 6. That upper bound is going to be replaced by pi over 2 because that's the highest it can be, right? Let me try to draw something here, okay? So before now, we had something like pi over 6, right? And 5 pi over 6. But now we see that the guys were symmetric about this guy. And this guy is just pi over 2. So that means I'm only concerned about this, right? Okay, I'm just concerned about pi over 2 and pi over 6. Now, why do I have a 2 up front? That's just because this is one part you're considering. Okay, so instead of doing it 2 times, this is another part you're considering. So you have these guys, okay? So that's why I have a 2 up front. Okay, so this is going to be 3 sine squared of theta, d theta, minus a 1/2 pi over 2 and pi over 6. If you square that guy, you have a 1 plus 2 sine theta plus sine squared of theta d theta, okay? So right here, you need your knowledge. I'm not going to take off this sketch so that you guys understand what I just explained. So this is where you now need your knowledge of integration, which we already learned, to integrate this guy. At the end of the day, my area becomes, this should be 3 squared, okay? That should be 3 squared. Because we do 3 sine theta, right? All squared. So this guy becomes pi over 6 to pi over 2. 9 sine squared of theta d theta. So if you have a question for me that, oh, what happened to the 2? What happened to the 1/2? Okay. So you know they can cancel, right? Minus, this is pi over 6, pi over 2. 1 plus 2 sine of theta plus sine squared of theta d theta. Okay. Now, what tools do we need from our toolbox? All right, this is sine squared of theta, sine squared of theta. You have to first rewrite that guy. Divided by 2. So then you do some kind of replacement. If you replace that guy, my area becomes got pi over 2, pi over 6. So if you look at this guy, now let me show you something, guys. This is 9 sine squared of theta, right? These guys are the same bounds, okay? So I don't want to lose anyone in the process of, trying to solve this guy. So if you have this guy, suppose I just have a here. I mean, let's just pick a. I mean, let's say the theta. A is a constant, all right? A is greater than 0. Let's say minus. Just call this guy pi over 6, pi over 2. Let's say you have a over 2 here, okay? This is a. Now, what happened, guys? They are the same bound. That means this I can just combine to have just a single bound. So this becomes something like this: a minus a over 2 d theta. Okay, so and that's the same thing we're going to see here. This is 9 sine squared of theta minus sine squared of theta. You have 8. Okay, you have minus this negative sign distribute over the other guy. So I have something like this. Okay, so am I free to plug in my sine squared of theta right now? Yes, guys, I'm free to do that. So let us plug it in. You have 8. 1 minus cosine 2 theta divided by 2. That's the first guy. Minus 2 sine of theta minus 1 d theta. So essentially, at the end of the day, what we're really working on is going to be from pi over 2 to pi over 6. Okay, I know the calculation might look a lot to you, but I need you to put your pen on paper and just try to follow these steps, and then you see that it's just like plug and play. Plug something in, you expect an output. So you get a negative 4 cosine of theta at the end of the day. Okay, so I could have skipped the whole of this, but I just want you guys to follow me. So now we're free to integrate this guy now. Okay, so that means this guy is negative 2 sine of 2 theta. This is going to be, if you integrate sine, remember it gives you negative cosine plus 2 cosine of theta. And if you, 3 is just a constant, so that means you have a plus 3 theta. But what about the bounds? Pi over 6 and pi. If you plug in the top and the bottom, at the end of the day, you just have a pi. Okay? You just have a pi. Okay, so I expect that you guys will be able to fill in the gaps over here. Just plug in the top. Okay, so I could just say plug in upper bound, subtract it from when you plug in lower bound. Okay, and then you get a pi. You get a pi. Okay, so one more example. Example 4. Now this guy says find all points of intersection of the curves. Remember, these guys are 4-leaved rows, okay? And r equals 1/2. R equals 1/2, of course, 1/2 is just a constant, right? Your angle theta is between your 2 theta, your theta is between 0 and 2 pi. So now remember, the question is to find all points of intersection. So now take a look at what we do in this case. This guy is a 4-leaved rows, right? 4-leaved rows. But what shape does this guy describe? It describes a circle with radius 1/2, okay? Radius 1/2. So I go from the area of sketch first, okay? So let's do the same thing again. 4-leaved rows, one loop, another loop, another loop, and then the final loop, okay? But that guy is a circle, okay? So that means I have to fit in a circle here. Okay, the radius of that circle is 1/2. Now, what are going to be my point of intersection? My point of intersection pretty much are going to be these guys, these red guys, okay? These guys. All right, so I need to know what angles correspond to those points. I need to know what angles correspond to those points. So this is what I do. Now, remember your theta is between 0 and 2 pi. But for the 4-leaved rows, you have a cosine of 2 theta, right? So that means to get your 2 theta, you multiply this guy through by 2. 2 is a positive number, so it doesn't distort the inequality. So this is 0 less than or equal to 2 pi, 2 theta here. Less than or equal to 4 pi, right? So what do? Remember how we do our POI, okay? Because that's what you're interested in. Cosine of 2 theta, set them equal to themselves. And your 2 theta is between 0 and 4 pi, right? So this guy becomes 2 theta, right, equals cosine inverse of 1/2. Okay, so this is my 2 theta on the left side equals, now what is cosine inverse of 1/2? Now you need your unit circle here, guys. The first thing you get is a pi over 3, and then you get others, okay? And your knowledge of trigonometry comes in handy here as well. 11 pi over 3. Now, how do I need theta out by itself? That means I have to divide by 2. So that means these guys are going to be pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Okay, so this is this guy. Now, however, I need to be able to get other points. Now, if you go back to the red guys, right? Think about these guys. Let us count how many of them we've got. This is 1. Let's start from here. 1, 2, 3, 4, 5, 6, 7, and 8. Now, 8 points. But what can I find so far? I only found 1, 2, 3, 4. If I stop here, then it's kind of half job. Okay, the job is not complete. So to get the other points, so for other points, what do I do, guys? For the other point, I'm going to set the same cosine of 2 pi, but in this case to the negative 1/2. Okay, so this guy, my 2 pi, similar to what I did before, but cosine inverse of negative 1/2, the first guy you get is 2 pi over 3. But of course, that's not the only thing on the unit circle. You get other equivalents. And how do you get theta? Divided by 2. So this guy becomes 2 pi, right? This becomes 2 pi over 6. 4 pi divided by 6. 8 pi divided by 6. 10 pi divided by 6. But in this case now, things you can still break them down, right? So this guy becomes pi, you can still simplify, that's what I mean. 2 pi over 3. And then this is 4 pi over 3 and 5 pi over 3. So what are the angles now? 1, 2, 3, 4, as well as 1, 2, 3, 4. So they're complete how many now, guys? They are complete 8. Okay. Actually complete 8, then that means we're good. Okay, makes sense, guys. Now, we're going to talk briefly again about arc length, but arc length now in the areas of, when you're given a polar equation. Okay, so arc length is a very easy part of this course. Now, when you're given r equals f of theta, okay? Now, suppose your angle theta is between A and B, and let us have the parametric guys, r sine theta. Okay, so what's the formula? My length is going to be from A to B. Okay, so this is going to be square root of the x d theta all squared plus dy d theta all squared d theta. But if you even want a more final result, okay, if you need a more final result, this is dx d theta. That means differentiate x with respect to theta. If you do that, you would have negative r sine theta. There will be some kind of computation. Once you plug it in, you will end up getting sine squared theta plus cosine squared theta equals 1. By the end of the day, you're going to have this simplified form: r squared plus dr d theta all squared theta. Okay, so whichever one of these equations, both of them are fine. If I give you r equals f of theta, you can just use the second formula immediately. a simple example to go with this guy. Find the exact length of the polar curve r equals 2 cosine of theta, where your theta is between 0 and pi. So keep in mind that this is my formula, right? So solution. L is, what is A? This is my A, this is my B. So you're going from 0 to pi, correct? So this is square root. What is R? So this is R squared in this case, plus dr d theta, right? So what is dr d theta? -2 sine of theta. I got a -2 sine of theta. I got a square here, d theta. Okay, so what would I notice? This is 0 to 2 pi. Now let's square things out. You have a 4 cosine squared theta plus 4 sine squared theta d theta, right? Is anything common? You have 4, right? 4 is common. If you take the square root of 4, you would even have a 2. So I can pull out a 2, 0 to pi, cosine squared theta plus sine squared theta. But talk to me, guys. What is this guy? This is just equal to 1. And what is the square root of 1? Square root of 1 is 1. Got 2 integral from 0 to pi d theta. All right. So finally, what do we have, guys? Just a 2 pi. Just a 2 pi. So the whole concept of arc length is a very easy part. So I'm not going to do a lot of examples here. I'm just going to stop here on this one because what you really need is just the formula. Okay. Once you have the formula, you'll be given R, square it, differentiate it, square the first derivative, plug things in, and then you rely back on your knowledge of integration. Okay. So nothing complicated. I think this is the third time we're seeing arc length in this course. And the only tweak, or the only thing we're tweaking, is actually how the content of the formula, but it's the same structure. Okay, before now it used to be 1 plus dy dx. Okay, I can still derive that from this guy too. I can actually still derive that as well. All right, thank you. So this is 10.4. See you in the next session.